46 last still weight. So for this problem, we are getting a stills array. So this is our stills array, and inside of the stills array, they're going to be stills. And let's also check the weight of the still. So it's going to be more than 1 and less than or equal to 1000. Yeah. So the idea for this problem is that we're going to check all the stills. Yeah. So for this problem, actually, we are giving this stills array, and inside it's going to be stills, and there are going to only be 2 conditions. So for each of the time, we're going to take out 2 stills. Yeah. So if they are equal, yeah. So if the 2 stills are equal, so they are destroyed. So it means nothing left. So if they are not equal, so the heavier still gonna minus the lighter still, and we're gonna get the final result, and we're gonna put it inside our stills array, and we're gonna continue to check like that. Yeah, we can also check the first example to understand. So first of all, we're gonna take out the 7 and 8, and we're gonna put 1 inside. And next, we're gonna just take out 2 and 4 and put 2 inside. And next, we just take out 2 and 1 and put 1 inside. Yeah. Next, we're going to take out 1 and 1 because they are equal, so it is equal to 0, we will do nothing. So it's going to still be this 1 and 1. It's going to be this only 1. So finally, we're going to return a 1. So this is going to be the last still. Yeah. Actually, yeah, this is similar like a game. So if the 2 still equal, they're going to be the same. If they are not equal, yeah, the game going to be heavier minus the smaller stills. Yeah. So best way to solve this problem is to use a heap. And for our problem, according to the problem, we're gonna first choose the 2 maximum stills, so it's gonna be a max heap. But in Python, we don't have max heap. So what are we gonna do? We're gonna first turn the array into negative values, because in Python we can use the negative values to represent the max heap. Yeah. So let's just prepare the stills. So we're going to turn all the values to negative, so minus n, so for n inside of the stills. Yeah. So secondly, we're going to heapify. Yeah, we're going to heapify the stills. So this means the stills array going to be a max heap. Yeah. Now what are we going to do? We just need to use a while loop to check. So while length of the stills, if while length of the stills is more than 1, definitely we can pop out the 2 values. So yeah, let's just say the 2 values are going to be a and b, and both a and b are negative values, but it doesn't matter. We're going to use a heap pop with the stills, and heap pop with the stills. Yeah, because the length is more than 1, it means at least we're going to pop out the 2 stills. Yeah, now we can check if a not equal to b. Because if a equal to b, it doesn't matter. We will not do anything. If a not equal to b, yeah, we just need to put it inside. So we're going to use a heap push with stills, and the value, we're going to use a negative value. We're going to choose the absolute of a minus b. Yeah, because it doesn't matter. Because if a not equal to b, yeah, it doesn't matter a is bigger or b is bigger, because we're going to use the absolute value. And finally, we're going to give a negative value. Yeah, because this is the max heap. So finally, we're going to return our result. So we're going to return a negative value. Yeah, because inside of stills, it's going to be negative value. So we're going to give a negative sign. So negative stills 0. So if there's something inside of the stills, else we're going to give a 0. So because the stills can become empty, this means nothing left. So we're going to return a 0. If there are no stills left, so we're going to return a 0. Yeah, now let me just run it and submit it to check. Yeah, still think this is a good problem. As you can see, it can pass. And yeah, the time complexity is n log n. And because this n is only 30, that is why it's so fast. Yeah, I think the problem is really clear and really easy to understand. And this is a very basic problem for practicing the max heap or min heap problem. I think that's all for it. Thank you for watching. See you next time.